Lesson 14, I can associate the ordered pair with each ratio and plot it in the XY coordinate plane. So we're talking about a little bit of new vocabulary today. If you were in my class, we spent some time going over it already. But for those of you who might have missed it, we're going to be talking about ordered pairs today, which will be a number separated by another number and then a comma. You've probably seen this pop up before, but that's what they're talking about when it's an ordered pair. We're going to be plotting them on a coordinate plane. So on a coordinate plane, you have a y-axis, which goes vertically, an x-axis, which goes horizontally. There's usually numbers below and on the side to label. So we might be taking a number, a ratio, turning it into an ordered pair, and then plotting them on the chart. That's what we're going to be getting into today, so let's go ahead and get started. Okay, let's take a look at this first one. Kelly is traveling by train with her soccer team from Yonkers, New York to Morgantown, West Virginia for a tournament. The distance between Yonkers and Morgantown is 400 miles. The total trip will take 8 hours. The train schedule is provided below. So this trip is going to be her trip there, and then because we can see she's leaving Yonkers and she's going to arrive at her destination in Morgantown. The whole trip takes 8 hours. So by the time she's gotten to Morgantown, West Virginia, she will have traveled 8 hours. And the whole trip is 400 miles. This is going to represent her trip back. So she's leaving Morgantown. She will travel another 400 miles to get home to Yonkers, New York. All right, so if we want to figure out, because part one is saying, exercise number 1 is saying create a table to show the time it will take Kelly and her team to travel from Yonkers to each town listed in the schedule, assuming the ratio of the amount of time traveled to the distance traveled is the same for each city. Then extend the table to include the cumulative time it will take to reach each destination on the ride home. So we need to figure out here how many hours it's going to take her to get to each of these cities. So if I know, for example, these are all, we're just looking for patterns. And one thing I noticed, there's a couple patterns. One that I noticed is that these are increasing by 100 miles. And if I wanted to scale this back down to 100, 400 divided by 4 would give me 100. So if I do the same thing on this side and I say 8 divided by 4, I'm going to get 2. Okay, so 2 hours, this would be 4 hours, this would be 6 hours, and 8 hours. Okay, and that's kind of how we can find the original ratio. You might also have just noticed the pattern that you saw 4 spaces here, and you might just say, okay, well, if it ends at 8, I know it goes 2, 4, 6, 8. So it just kind of depends on if you're more like a visual pattern person, but if not, you can recognize what do I need to do to this number to get me to my original. 400 divided by 4 is 100, so I could do the same on that side as well. Okay, so I'm gonna go ahead now and start working on my table now that I have this information that I need to get started. So let me zoom in a little bit. All right, so what we figured out, our original ratio is 2 to 100. So I just started adding those into our chart. So 2 to 100. Okay, then by the time she gets to Allentown, 4 to 200 miles. Add another 2 hours and another 100 miles. Gives me 6 to 300. Next I have 8 to 400. And that is the full distance there to Morgantown. Now, if I look back at the directions, they say to extend the table to include the cumulative time it will take to reach each destination on the ride home. That word cumulative just means like the total number of hours. So like how many hours traveled, not thinking about any time that she spent off of the train, but how much time traveling altogether. So 8 hours traveled, we'll leave her at 400, but now we're going to include the travel time home. So I added another 2 hours to go another 100 miles to get me to 10 hours traveled, and we have now traveled a total of 500 miles. Okay, same thing, 12 hours traveled will get me to 600 miles. 14 hours traveled will get me to 700 miles. And 16 hours traveled, she'll be back home, and she traveled the full 800 miles. 400 miles there, 400 miles back. The total trip takes 8 hours, so another 8 hours to get home, 16 hours. Everything fits just like a puzzle. I bet now you're just sitting there saying, wait a second, this seems like review. I know how to figure out ratios and extend ratio tables. Where is the content goal playing in here? I thought we were going to be talking about some exciting ordered pairs and coordinate planes. And yes, I know you're so anxious to do that because you just love math so much, and we are heading in that direction. First, we're going to come back to everybody's other favorite thing of all time, which is double number lines. Aren't you excited? I know I am. All right, so number 2 says create a double number line diagram to show the time it will take Kelly and her team to travel from Yonkers to each town listed in the schedule. Then extend the number line diagram to include the cumulative time it will take to reach each destination on the ride home. Okay, that's the data that we just plugged in the last one. All that cumulative time traveled, all the miles traveled. Represent the ratio of the distance traveled on the round trip to the amount of time taken with an equation. All right, let's get started. Okay, here we go. So we're just going to plug this information onto our number graph, our double number line diagram. That's a mouthful. So this line going across here is going to be our hours, and down here is going to be our miles traveled. So, I mean, we could start with 0. You traveled 0 hours, you get nowhere. You're at 0 miles traveled. Now we travel for 2 hours, we get 100 miles. 3 hours, you get, 4 hours, because it's increasing by 2, Miss Rotundella. We're increasing by 2, the ratio is 2 to 10. So 2 hours is, 4 hours is 200 miles traveled. 6 hours is 300 miles traveled. And you get that, so go ahead and complete the rest of the number line. Stop when you get to the end. Okay, so filled it all the way down in. It matches our table. We ended at 16 hours traveled, 800 miles traveled. So using the information from the double number line diagram, how many miles would be traveled in 1 hour? So I bet a lot of you guys, you just quickly know the answer to that, but we want to be able to prove it on our double number line. So 1 hour would be right about here. Okay, so I want to know how many miles that it was in 1 hour. Let me zoom into that section. So I know the amount traveled here, the distance is 100 miles from 0 to 100. So half of that would be 100 miles times 1/2. Okay, and if I add the 1 onto the bottom, 100 over 2, do you know what that would reduce down to? 50. So 50 miles. Okay, and it's really important that even though I bet a lot of you were like, oh, I know half of 100 is 50. The directions do say to represent the ratio of the distance traveled on the round trip to the amount of time taken with an equation. So we are going to make sure that we have an equation at the very end. Also, it says down here, how do you know? So this is where we get to do some explaining of our thinking. We know, well, what did we just do? We know that in 2 hours you can travel 100 miles. So we know that in 2 hours you can travel 200 miles. So half that time is going to be 1/2 times 100. Which is equal to 50 miles. So we know that in 2 hours, you can travel 200 miles. Half of that time will be 1/2 times 100 equals 50 miles. Oops, this should only be 100 miles. All right, guys, who's making bets on how many mistakes I can make in one video? I think that's like the 5th one already today. All right, so again, because we said it's 100 miles from in 2 hours. So half of that, half times 100 equals 50 miles.